Good morning. My name is Jim Kramer with the AQCS Safety and Security Coordinator. I'd like to take the opportunity today to give you a brief tour of what's been going on at the Big Stone Plant. So come along with me and see what we can see today for you. Today, as most days are going on, we have beautiful weather. You'll see iron workers that are perched onto the steel. You'll see an effort where we have 100% tie-off at the project, which means that at no time when you're exposed to a 4 feet or more, those persons have to be tied off to a anchor point of 5,000 pounds or greater. When the project started, one of the main scopes was preparation of the ground, leading up to the excavations for concrete. Also storm sewers for drainage, rainwater and the like was provided, along with the underground fire protection systems were rerouted and replaced.
A year before it started, we took what was a field out in front of the plant and we leveled that and graded it and put gravel on it, and we've got 26 acres of what we refer to as laydown area to store equipment and materials. And we've gotten over 1,100 semi-loads of material and quickly filled that 26 acres, and anybody who's on the plant site sees we're storing material in any corner or any flat spot that we can get.
This was the very beginning of the project where the excavation started. In the planning process, it was determined to keep the workers active and productive. The scope of the work was to get the building built and sided and temporary heat installed before the difficult winter of 2013 and 14 set in.
One of the things that a lot of people lose sight of is the fact that we do have an operating coal plant that we are building this project around. Whatever we're doing, we do not want to impact the operations of our existing unit. There's a lot of coordination and communication that occurs on a daily basis. We have members from the AQCS project team attend the Big Stone Plant meetings on a daily basis and on a weekly basis, making sure that that communication is continuously flowing in both directions, and it's been very successful.
When you look over to the south, you see the main two coal conveyors that supply coal to the Big Stone Plant. That conveyor runs directly through the SCR steel. So the engineering, the load testing, and clearances had to be designed well in advance to incorporate that activity.
Well, the plant was originally built in 1975 for about $170 million. This addition is almost 2.5 times that dollar value. We've had upgrades and replaced equipment along the way that have been tens of millions of dollars, but nothing anywhere near the size of this retrofit of the air quality control system.
What you're looking at is a lot of structural steel that's been set in place for the SCR, the Selective Catalytic Reduction effort, is one component of the AQCS project.
Well, what this project is doing is really making Big Stone a state-of-the-art as far as the control of the three pollutants, NOx, SOx, and mercury. We're going to be able to produce levels of emissions that are comparable to a brand new plant. So we're really making this state-of-the-art. It's giving the plant a new life that should make it viable for many, many years in the future.
We're rerouting the gas flow out of the boiler. Once the coal is burned and it's on its way to the existing bag house and stack, we're now going to reroute that. So the actual part you're seeing is the ductwork, the gas flow ductwork. Once it goes through the SCR, it will then go back into the plant just above the air heater to capture the residual heat, go through the air heater, and then go out to the scrubber, which we'll see here momentarily. What you're seeing today will continue to grow for about 100 more feet vertically. So when complete, the SCR component will be probably 260 feet from grade level. This is actually elevation 1159, or the second floor of the baghouse area. We're standing adjacent to one of the scrubber trains, and this is the component that will scrub the sulfur dioxides out of the gas flow. So you see here one that's all insulated. If you look to the other side, you can see one that'll be completed with lagging. A train for us, it just means that there's two separate gas flow paths, that we're able to isolate one and work on while we keep the other one operational. It's kind of like dual exhaust on a car. If one exhaust quits, you can still have a little bit of exhaust going out the other. Same theory. So that's really what we're doing. We're just modifying the exhaust of the plant, much like the exhaust on a car.
Primarily, I am the key interface with Graycore, our general work contractor. They've been excellent. They have a very good project management staff, engineers, QA, QC personnel. Their safety personnel are top-notch. We have a very good safety record on the project, which speaks a lot to Graycore's attention and dedication to safety on the project site.
What you see there of Graycore's cardinal rules, a violation of any of those 7 rules provides immediate termination off the site. We take it seriously. We don't want to get anybody harmed. It also causes you to lose your employment at the site. So very, very strict.
For safety, when we started approaching this project, we wanted to set the bar higher, shall we say. So we're doing things on safety that have not been done before. One of the things we're doing is requiring all of our contractors to have one dedicated safety person for every 50 workers. And right now we have got over 10 people out there every day that their only job is safety. We're halfway through the project and doing very well. We're approaching 1 million man-hours on the project, and we've had only 3 recordable injuries and no lost time.
You will notice through the video that high-vis torso requirement, hard hats, safety glasses, steel-toed shoes or safety-toed shoes. We've made a lot of implementations to exceed existing OSHA rules and Big Stone Plant rules. We reduced the speed limit around the site from 15 to 10 miles an hour. When moving equipment such as forklifts, you will have an assist to escort you, make sure personnel are clear, material is clear, so we can contribute to do that. You can see that the use of articulating boom lifts and scissor lifts is a major component. All operators that are involved in using one of those lifts have to receive on-site training from the manufacturer. So that's an ongoing process with all the new hires that come and leave. The largest lift that we've had on site for articulating boom lift is 150 feet. Today on site, we have approximately 400 contractors that are working on the AQCS project. That does not include the AQCS staff or the Big Stone staff or crafts people. So today total we have approximately 500 people that are located on the site.
We've got over 15 different classifications of union labor out here.
We have boilermakers, we have iron workers, we have millwrights, we have electricians, we have pipe fitters, we have carpenters, we have painters, we also have excavation people, civil foundations, actually have all facets of all trades that are used in a construction facility.
And they're coming from all over the country. We've got people from East Coast, West Coast, a lot of guys from down south. I think Graycore did a very good job of holding contractor pre-jobs in which they laid out very specifically which craft was responsible for doing which task.
Almost no one is from the area, so we've got 425 additional bodies in the community, buying breakfasts, buying hotel rooms, buying fishing license. So the local economy is seeing that positive influence. Of course, there's more traffic on the highway and such, but so far we're half done with the construction. There really hasn't been any serious problems, so things are going well.
What you see out front here is just a small area that's designated for preparation for lifts. This is where the iron workers will bring up equipment or material, prefabricate to a certain specification or certain weight limit, and then they'll get ready to lift that. It's more feasible, and most importantly, it's more safe to do that work at a lower level, have a quality check, and ready to lift and put into place so that reduces the impact of exposing workers up to the upper levels. What you'll see attached to there is not only are they flying that piece up, you'll see on the end there's a bag kind of pink coated. That's their bolts and nuts to put it together. So they don't have to haul the bolts up to it. They secure it right to the member, so it's right where it needs to be. Right now on site, we have approximately 10 cranes, and they range from 35 ton to the largest crane is actually rated at 750 ton capacity.
The biggest crane actually came from Belgium, and it took over 50 semi-loads to get the crane on site and then assemble it. It's a monster, and that's probably the most impressive thing so far, is to see that come in and go up.
The largest lift to date so far is 260,000 pounds, and the largest lift anticipated for the project is roughly 430,000 pounds we will lift in one lift. What you'll see to the south here is two large tanks. This is going to be the anhydrous ammonia storage facility. The anhydrous ammonia is diluted with the airflow. It then mixes with the catalyst, or reacts with the catalyst that's involved in the SCR. And this is the chemical reaction that reduces the nitrogen oxides that are involved in the SCR component. And this contributes to the smog component that we're trying to reduce as part of the AQCS project. The anhydrous ammonia system was purposely put where it's at, away from the people, away from the process. It is classified by OSHA as an extremely hazardous chemical. The safety components, the emergency eye wash stations, the lighting, egress, access, all these components are built into protection in case of any leaks or excursions that would happen. It has its own dedicated fire component that will provide a fog stream and deluge system over top of the tanks and or over the unloading system and pump systems. If there was ever an excursion, these would automatically start and they would deluge the anhydrous ammonia, scrubbing it to the ground with a full containment around the area. Of course, this is the existing stack. What you see on the ground here, you see some structural steel. These will be the supports for the new exhaust duct or discharge duct from the ID fans that are assembled just to the south of here. That ductwork will be removed. What you see there today, those two L's on each side, that will be removed. So that will leave those holes that go into the stack will actually remain. The new ductwork will come up and then we'll use the same existing hole. So we won't have to make any modifications to the stack. The new brown building that you see here is the bag house. This incorporates the scrubber component and the bag house area. It's going to be quite large when complete. This will be 200 feet above ground complete with the building. The components for the bag house, what you see there are the intermediate modules at the top level. Yet to go on top of that is the top module where the clean air, once gone through the bag house, will then be pulled down to the ID fans and exit to the stack. These two large components you see with the motor assemblies on them, that's the ID fans. These will replace the 4 existing ID fans. These are variable frequency drive fans, more feasible to run, to operate. Very large components, some of the biggest fans that are used for this application up in this part of the country. Well over 12,000 horsepower motors. And of course this will be what provides the draft from the boiler through the SCR, through the scrubber, and through the bag house, then exit to the stack. Because of the new process and the large amount of ash that we'll be handling, the decision was made to build a new waste ash silo. Alongside of it is the pebble lime storage silo. When the project is completed, the existing waste ash silo, the one located farthest to the south, will be demoed and removed from the site, and we'll be only using the new one.
Well, this is, a huge project, pretty obvious, and it covers roughly 10 years from the start of it to the time that the last bill is paid. It began with environmental monitoring that the environmental service area did. We then had permitting that the environmental service people and legal were involved with. There was rate recovery, all of that before we got to the engineering point of the project, where we went out to outside firms, hired contractors, and then the corporate people had to be involved on the finance side, the insurance side. So just about every aspect of the company had some part, small or large, to play in having this all come together.
Well, it's a big project. And so as we put our project team together, there were a lot of questions on whether or not we were going to be able to pull this off without leaning too heavily upon consultants and outside engineering firms. I think through this process there's been some bumps in the road, some ups and downs, and we've learned a lot about how to effectively manage a construction project of this size. And you look at all the key performance indicators that we monitor, schedule, cost, productivity, safety being number one, all those indicators point to a project that is very successful.